Hi, I'm Megh Talati with my team members Sangeeta Bhattacharjee and Sneha Mohan. And today we are going to do a presentation on our research topic that's microservices and web application. So, before jumping into microservices, let's see how traditional monolithic architecture works and how its limitation led to a transition to microservices. Monolith means composed in all in one piece. The monolithic application describes a single-tier software application in which different components combine into a single program from a single platform. The different components can be authorization, which is responsible for authorizing a user, presentation, which is responsible for handling HTTP requests and responding it with either HTML or JSON or XML. Then comes business logic, which is the application's business logic. Then database layer that accesses objects responsible for accessing the database. Then comes application integration, which integrates with other services, that is via messaging or REST API, or integration with any other data sources. And last, the notification module, which is responsible for sending email notifications whenever it's needed. So the following image shows a architecture for monolithic web application, which has two primary components, a relational database and a server-side application. The server-side application here will do the heavy lifting of whatever operations that has happened. The server-side application will take care of the handling the HTTP request from the clients, retrieving data from database, update database with the new data, giving proper HTML responses to the clients. This is the traditional way of building the web applications. Here, all the business logic for servicing a user request is packed into a single application process, which will typically be running in an application. All different features of the application is written as separate modules and classes and will ultimately be packed into a single large application. But the drawbacks of the monolithic architectures are that the application is too large, that it can slow down the startup time, and it's too complex to fully understand. Then we must redeploy the entire application on each updates. The simple approach of monolithic architecture has a limitation in size and complexity. Application is too large and complex to fully understand and make changes fast and correctly. The size of the application can slow down the startup time. You must also redeploy the entire application on each update. Impact of a change is usually not very well understood, which leads to do an extensive manual testing. Continuous deployment is also difficult. Monolithic applications can also be difficult to scale when the different modules have conflicting resources requirements. Another problem with monolithic application is reliability. Bug in any module can potentially bring down the entire process. Moreover, since all instances of the application are identical, that bug will impact the availability of an entire application. Monolithic applications has a barrier of adopting a new technologies. Since changes in framework or language will affect an entire application, it is extremely expensive in both time and cost. So, to overcome the drawbacks of monolithic architecture, the microservices architecture were introduced. While a monolithic is a single large unit, a microservice architecture uses small, modular units of code that can be deployed independently of the rest of the product's components. There are many ways to build a microservice architecture, but most of them share the fundamental characteristics. Microservices components are modular, so each services can be built, updated, and deployed independently of any other code. Each microservice is only responsible for a specific purpose of task. Microservices receive requests, process them, and send a response. Microservices abstract away implementation details, only exposing a well-documented interface, so API can be consumed in a consistent way regardless of how exactly the service is built. Overall, the microservice architecture is largely the same as the monolithic architecture, where you have a user interface, some functions, and a database. With microservices though, those functions are all separate. They communicate with the user interface, each other, and the instances of the database. A team designing a microservice architecture for the application will split all the major functions of an application into an independent services. Each independent service is usually packed as an API, so it can interact with the rest of the application's element.
Hi, this is Sneha Mohan Mannarath. Today I'm going to talk about other aspects of microservices. So let's see how messaging in microservices works. So we are going to talk about two kind of messaging today. The first one is synchronous messaging using REST API or Thrift. The second one is asynchronous messaging using AMQP, STOMP or MQTT. So for synchronous messaging, client expects a timely response from the service and waits till it gets it. In microservices architecture, REST is a unanimous choice as it provides a simple messaging style implemented with HTTP request response based on resource API style. Therefore, most microservices implementations are using HTTP along with resource API based styles. Also, Thrift is used as an alternative to REST HTTP synchronous messaging. The next one is asynchronous messaging. So for some microservices scenarios, it's required to use asynchronous messaging techniques since client doesn't expect a response immediately or not accepts a response at all. In such scenarios, asynchronous messaging protocols such as AMQP, STOMP, or MQTT are widely used. In the next few slides, I'll be talking on integrating microservices. In microservices architecture, the software applications are built as a suite of independent services. So, in order to realize a business use case, it's required to have the communication structures between different microservices or processes. That's why inter-service or process communication between microservices is such a vital aspect. Now we are going to discuss about point-to-point style. So in point-to-point style, the entire message routing logic resides on each endpoint and the service can communicate directly. Each microservices expose a REST API and given a microservice or an external client can invoke another microservice through its REST API. Obviously, this model works for relatively simple microservices based applications, but as the number of services increases, this will become overwhelmingly complex. The next one is API gateway style. So the key idea behind the API gateway style is that using a lightweight message gateway as the main entry point for all the clients or consumers and implement the common non-functional requirements at the gateway level. In general, an API gateway allows you to consume a managed API over REST or HTTP. Therefore, here we can expose our business functionalities which are implemented as microservices through the API gateway as managed APIs. In fact, this is a combination of microservices architecture and API management which gives you the best of both worlds. In the figure, a retail business scenario is shown. Here, all the microservices are exposed through an API gateway and that is a single entry point for all the clients. If a microservices want to consume another microservice, that also needs to be done through the API gateway. The API gateway style could well be the most widely used pattern in most microservice implementations. The next one is message broker style. The microservices can be integrated in asynchronous messaging scenarios such as one-way request and publish subscribe messaging using queues or topics. A given microservice can be the message producer and it can asynchronously send message to a queue or topic. Then the consuming microservice can consume messages from the queue or topic. This style decouples message producers from message consumers and the immediate message broker will buffer messages until the consumer is able to process them. Producer microservices are completely unaware of the consumer microservices. The communication between the consumers producers is facilitated through a message broker which is based on asynchronous messaging standards such as MQP, MQTT, etc. Now we are going to talk about service registry and service discovery. In microservices architecture, the number of microservices that you need to deal with is quite high. And also their location change dynamically owing to the rapid and agile development or deployment nature of microservices. Therefore, you need to find the location of microservice during the runtime. The solution to this problem is to use a service registry. Service registry holds the microservices instances and their location. Microservice instances are registered with the service registry on startup and deregistered on shutdown. The consumers can find the available microservices and their location through service registry. To find the available microservices and their location, we need to have a service discovery mechanism. There are two types of service discovery mechanism, client-side discovery and server-side discovery. Let's have a closer look at those service discovery mechanisms. First one is client-side discovery. In this approach, the client or the API gateway obtains the location of a service instance by querying a service registry. The next one is server-side discovery. With this approach, the clients or API gateway sends the request to a component that runs on well-known location. That component calls the service registry and determines the absolute location of the microservice. Now I'm going to talk about deployment of microservices. When it comes to microservice architecture, the deployment of microservices play a critical role. There are key requirements for this such as ability to deploy or undeploy independently of other microservices, must be able to scale at each microservices level, building and deploying microservices quickly, failure in one microservice must not affect any of the other services. Here we are explaining the steps to deploy a microservices using Docker, which is an open source engine that lets developers and system administrators deploy self-sufficient application containers in Linux environment. The key steps to deploy using Docker are: first, we have to package the microservice as a Docker container. Then each service instance has to be deployed as a container. As the number of container instances change, we have to scale it accordingly. The building, deploying, and starting microservice will be much faster as we are doing Docker containers. Now we are going to talk about security and commonly used security standards in microservices. Securing microservices is quite common requirement when you use microservices in real world scenarios. The widely used API security standards are OAuth 2 and OpenID Connect. OAuth 2 is an access delegation protocol. The client authenticates with authorization server and gets an opaque token, which is known as access token. Access token has zero information about the user or client. It only has a reference to the user information that only can be retrieved by the authorization server. Hence, this is known as a by reference token, and it is safe to use this token even in public network or internet. Next one is OpenID Connect. It behaves similar to OAuth, but in addition to the access token, the authorization server issues an ID token which contains information about the user. This is often implemented by a JSON web token that is signed by authorization server. So this ensures the trust between the authorization server and the client. JWT token is therefore known as by-value token as it contains the information of the user, and obviously it's not safe to use it outside the internal network.
Hi, I'm Sangeeta Bhattacharjee. Today I'm going to talk about the advantages and the applications of microservices. Microservices tackles the problems of complexity by decomposing the application into a set of manageable services which are much faster to develop and much easier to understand and maintain. It enables each services to be developed independently by a team that is focused on that services. It reduces barrier for adopting new technologies since the developers are free to choose whatever technologies make sense for their services and not bounded to the choices made at the start of the project. Microservices architecture enables each microservices to be deployed independently. As a result, it makes continuous deployment possible for the complex applications. Microservices architecture enables each services to be scaled independently. Let's see some of the tools used in microservices. First, Spring Boot. Spring Boot provides a good platform for Java developers to develop a standalone and production-grade Spring application that you can just run. You can get started with a minimum configuration without the need for an entire Spring configuration setup. In Spring Boot, everything is auto-configured and it offers annotation-based Spring application. Next is Docker. Docker is an open platform for developing, shipping, and running application. You can develop application very fast and deploy them fast. Using Docker, it is easy to create required services separately and manage them as microservices without affecting the other services. Amazon Lambda. Amazon Lambda is a service which performs serverless computing, which involves computing without any server. The code is executed based on the response of events in AWS services, such as adding, removing files in S3 bucket, updating Amazon Dynamo DB tables, HTTP requests from Amazon API gateway, etc. To get working with AWS Lambda, we just have to push the code in AWS Lambda services. Next is Swagger. Swagger is an open source software framework backed by a large ecosystem of tools that helps developer design, build, document, and consume RESTful web services. While most users identify Swagger by the Swagger UI tool, the Swagger toolset includes support for automated documentation, code generation, and test case generation. Lastly, we'll be talking about Kubernetes. Is an open source container management tool hosted by Cloud Native Computing Foundation. Kubernetes comes with the capability of automating deployment, scaling of application, and operation of application containers across clusters. Let's compare both monolithic and microservices architecture. In deployment, monolithic apps allows you to set your deployment once and then simply adjust it based on the ongoing changes. In microservices, you will need to deploy each microservices independently. In reliability, microservices architecture is obvious winner here. Breaking one microservices affects only one part and causes issues for the clients that uses it but no one else. Scalability, monolithic apps are hard to scale, but with microservices, resources can be used more carefully and allow you to scale only that part that requires more resources. In cost is tricky to calculate because monolithic architecture is cheaper in some scenario but not in others. On the releasing front, microservices that are smaller and with proper architecture of microservices communication allows you to release new feature faster by reducing the QA time, build time, and test execution time. Monolithic apps have a lot of internal dependency that could not be broken up. In this slide, let me explain an example of a shopping cart application. When you open an application, all you see is just a website. But behind the scene, it has a service for accepting payments, a service for customer service, and so on. Assume the developer of this application have created it in a monolithic frame. So all the features are put together in single code base and are under single underlying database. Now, if there is a new brand coming up in the market and the developer wants to put all the details of upcoming brand in this application, then they not only have to rework on the services of the new labels, but they also have to reframe the complete system and deploy it accordingly. To avoid such challenges, it is better to shift the application from a monolithic architecture to microservices as seen in the second diagram, where all the functionalities are kept in the different modules and hence can reduce the rework needed. Let's see some real-world example of Uber's transition from monolithic to microservices. Uber began its journey with a monolithic architecture built for a single offering in a single city. Having one code base seemed clean at that time and solved Uber's core business problem. The before diagram depicts Uber's previous architecture. A REST API is present with which the passenger and driver connects. Three different adapters are used with API within them to perform actions such as billing, payments, sending emails, messages that we see when we book a cab. A MySQL database to store all their data. So if we noticed, here all the features were composed with a single framework. There are many challenges faced by Uber with this architecture on worldwide expansion. All the features had to be rebuilt, deployed, and tested again and again to update a single feature. Fixing bugs became extremely difficult in single repository as the developer had to change the code again and again. Scaling the feature simultaneously with the introduction of new feature worldwide was quite tough to be handled together. To avoid such problems, Uber decided to break its monolithic architecture into multiple code bases to form a microservice architecture. In the after diagram of Uber microservice architecture, the major change that we observe here is the introduction of API gateway through which all the drivers and passengers are connected. From the API gateway, all the internal points are connected such as passenger management, driver management, trip management, and others. The units are individually separate, deployable units and performing separate functionalities. All the features are well now scaled individually in this way. Uber benefited by shifting its architecture from monolithic to microservices. The wave of hype and excitement about microservices continues unabated. Understanding exactly why and how your organization will benefit from microservice architecture is an important first step to adoption and shouldn't be left as an afterthought. Microservices can be a great solution if a monolithic has gotten too big or complicated. Microservices architecture can be adopted when we need quick independent service delivery and a piece of your platform needs to be extremely efficient. When your team is bigger and has microservice experience, then we can shift to microservices. Here we come to end of our presentation. Thank you for listening to us. Hope you enjoyed our presentation.